I've been putting off this build for far too long. I've had all these parts kicking around for like over 6 months now, and I think it's finally time that I actually get to building this thing. But first, just a bit of channel housekeeping is in order. If you're a new subscriber, thank you so much. We just passed 200 subscribers, and I feel more motivated than ever to continue documenting my projects and making videos for y'all. I've been making a lot of shorts recently, but I made a promise in one of those shorts that I would be working on a Game Boy Advance SP, doing the full rebuild and the screen replacement. So if you subscribed after seeing that video, don't worry, that will be the next long form video that I make, so just hang tight for that. But if you've been subscribed for like 5 years, ever since I've been making like crappy FPV drone content, first of all, thank you for sticking with me all these years. And second of all, you're in luck, because today, as you can clearly see, we're gonna be doing a quad build. This is gonna be a 7-inch long range drone, which I'm pretty excited about. So this is just gonna be the first in a series of videos where I build and test and tune this quad, but mostly just continually add a bunch of upgrades along down the line. So without further ado, let's get into this build. Let's just go through the parts real quick. So starting off with the frame, I went with a clone GEP-RC Mark IV frame. I'm actually really impressed with how good these like clone or knockoff frames are getting these days. I also just got it because I thought it looked cool, to be honest. It's a pretty sweet looking frame. It's got that kind of skinny profile. It seems pretty easy to build into. But yeah, so that's the frame. GEP-RC Mark IV clone. I think it was like $10 on AliExpress. It actually came with aluminum standoffs, but I got some nicer looking standoff in black. You know, I just wanted to make it kind of black on black, murdered out, if you will. For the flight controller and ESC stack, I went with this Speedy Bee guy. This is a F4 flight controller and a 55 amp ESC. Nothing special, and I know F4 is like a dated thing now. You should really be buying F7, but this was really cheap, and hopefully Betaflight and INAF will continue to support F4 for at least a few more years to come. It's got all the features I would really want. Yeah, and it probably would have been safer to go a little bit higher on the amp rating for the ESC. Probably would have preferred a 60 amp ESC. Let's just hope this doesn't come back to bite me. But I think as long as the rating here is conservative, and as long as I don't push it too hard, I think it'll probably be fine. But I would recommend, if you're building your own 7-inch, just go with a 60 amp ESC. It's going to be the safer call for sure. It's got all the features I need. It's got plenty of UARTs. It's got an I2C connection for the compass on the GPS that I'm going to put in here. It's got black box. It even has a little memory card slot for black box. The ESC, nothing special either. Only an 8-bit. It's not a 32-bit ESC. It looks sweet. So that's the stack. So the camera I chose to put in this thing is a Runcam Phoenix SE. Maybe if I win the lottery in the future, I'll convert this quad to digital. But for now, I think this little Runcam will do. There's an extra plastic shroud on here that has these little bumps on the front, so it provides some camera protection, and I like that design as well. So yeah, that's the camera. And for the VTX, I went with this 3-watt Jobby from Axis Flying, who I'd never heard of before I bought this. They seem like they focus more on like the commercial drone market, and they call this thing the Turk. I think that they meant to call it the Trek, but they just got the letters mixed around. I may be wrong. But yeah, 3 watts, that should be plenty of analog juice to get me pretty far. And I picked out this long iFlight antenna just so I can get it up away from the frame as far as possible and maximize our range. So yeah, this thing looks pretty sweet too. It's got a freaking cooling fan on it, which I think is ridiculous for something that's going to be on a drone that's flying through the air, but whatever. It's got to dissipate 3 watts worth of heat, so I guess it makes sense. If you're just idling, it would probably overheat like instantly without that. Yeah, and I already put some standoffs on here. So I'm gonna be mounting this in a pretty unconventional way, you could say. And the motors, coincidentally, are also from Axis Flying. I didn't do that on purpose. There was just a good deal on these at the same time I was buying the VTX. They're 2807 size and 1350 kV, because I plan on making this a 6S build. Nothing special. It's a 2-piece bell design. They're nice and clicky feeling, and they're chunky. I think they're going to do the job just fine. And last but not least, I'm going to be using this ELRS receiver. It's a RP3V2 from Radiomaster. 2.4 gigahertz. It has antenna diversity, not like true diversity. It's not the highest performing long-range receiver you can get, but it really should give us plenty of range. Probably more than I'm comfortable flying anyways, so I already put some heat shrink on it. So I guess there's nothing to it but to do it. Let's quit stalling and get this thing built. I think I'm gonna start by taking off the top plate of this frame and then mounting the stack, screwing on the motors, and then we'll solder the motor wires onto the ESC. Be a good place to start as any. All right, let's do that. I'm going to be doing things a little bit out of order because the way I have to mount this VTX is a little bit unorthodox, and I'll be mounting this underneath the quad. I know it's ridiculous, but it's the solution I came to. Basically, it wouldn't fit back here, and that's like the only other mounting holes. This is a 20 by 20 millimeter mounting hole, so yeah, under the quad it is. And as long as I have some landing gear that get me that clearance, I'll be fine. If it's stupid and it works, then it's not stupid, even if it's stupid. So these are little 1.5 millimeter standoffs. Okay, good. I can still get a screwdriver in the stack screws in case I need to rekajigger things. Our ESC back in this way. Plenty of room to spare. I think we're good. Okay, so now that we have the VTX on, we can solder our motors on. Okay, stop stalling, build the fucking quad. Get our motors out. I highly doubt that this is FCC or CE rated or ROHS compliant. They give us 5 motor screws per motor, which is nice of them. Let's check the wire length. Oh, they gave us way more than enough. Yeah, that's good that they do that. So I realized that we should probably solder on the XT60 lead before we solder the motors on, because it's going to be a lot more difficult to solder it in once it's in place. So, and obviously while we're doing that, we might as well solder on the capacitor too. So I'm going to go ahead and get this capacitor soldered on there. Start with the negative because it's the most bastardly. Iron. I'm going to crank the iron up. It's only at 350. So. That's beautiful. See how the solder like flattened out on that one? All right, I'm happy with that. Still a little bit cold. You know what? I have a secret weapon for the main connector. Go ahead and crop these leads. I'm gonna pull out my secret weapon. This is my secret weapon. It's an old Weller soldering iron. It's just got a mains plug on it. So this thing has the most freaking thermal mass of any iron I own. And it's old school. It's like meant for through-hole components. You can tell because it has that little notch in there. That's for like grabbing onto a leg of a through-hole component and soldering it. So this thing will solder whatever I throw at it. So I think that's going to be the ticket for soldering these on. I'm going to have to let this heat up, which is going to take a while. So one moment. All right, got this all stuck down. I really need to just buy me some helping hands already. I'm going to really glob the flux on here. Gonna need it. And I got my iron hot, so let's just hope for the best. Start with the negative because that's gonna be the most painful one. Now I'm gonna solder the outside too, because there's basically, it's like a via cut in half on this side, so I'm going to put more solder on this. Pretty good. Yeah. A lot easier when you have the right tools. Yep. Nice and shiny. Nice fillets. You can see there's 2 fillets on this one because of I had to reflow this edge. And the positive looks better, pretty much. The fillets are going inwards instead of blobby like this, but I would say that's a good solid joint. If If you look at the top here, the solder from the capacitor is coming out through the hole in the top. So that tells me that's fully soldered in too. And it actually looks kind of clean like that with barely any solder on the top pads, but the bottom pads just flooded. Did I get it the right direction though? Yes. Woo-hoo. That's always a fear of mine. Positive is red, negative is black. Good. Just did a quick little test fit here with the top on. That's fitting on there perfectly. And I guess all that's left is to get the motors on. I'm gonna turn my iron back down to 375. And in fact, I'm gonna turn it off for now because I forgot I need to actually screw the motors in first. These screws gonna be too long. You can see it just barely pokes out. I would rather it be totally flush, but I think that's fine. I don't think it's at any risk of touching the windings, even though it is like a couple millimeters away only. 2mm hex driver. Put these motors on. All right, we've got the motors on. What's sort of weird is that the wires come off like a little bit to one side on all the motors. I'm not sure what that's about, but it's really not a big deal at all. I think that I'm going to get these arm guards on now. That'll just help hold down the motor wires. It'll make it easier because they won't be flopping all over the place, so. Looks pretty clean, actually. All right, well, I'm gonna do that for the rest of the arms. All right, now that's done. It looks way cleaner, in my humble opinion. So now all we gotta do is solder on the motors. And if you're new to quad building, you don't have to go in any particular order. I'll just get them laying flat so they look nice and neat and tidy. And then I'll cut them so that it'll just reach to the edge of the pad. But I'll add a couple millimeters just so I don't screw myself over. And I'll do that for all the motors. On my iron. I got it set at 375 now. Should be fine. I'll start by just tinning up the wires. Next, I'll tin up the pads and add some flux first. More flux. One, sloppy. Two, bit better, but still sloppy. Three is pretty darn good. Now that my shoddy soldering skills are on full display, I'm gonna go ahead and just fast forward through the rest of this stuff. You don't need to see me struggle any more than I already have. So yeah, we'll come back when all these motor wires are soldered onto the ESC. Not my best work, but also not my worst work. You can see these are my first ones that I did at the very start. Look pretty just ugly. They're not necessarily bad or cold or weak, but they're ugly. Then you go to the other side. Yeah, technique was a lot better by then. So this always happens with these soldering projects. I like completely forget everything I know because I haven't soldered something this big in like months. But yeah, you know what? It will work. All right, well, that's a big milestone done. We got ESC and motors, so the whole drivetrain is complete. So I was looking at the pinout of this, and this SpeedyBee flight controller has a really, really in-depth manual. It's pretty awesome, actually. It has features that I didn't even realize were there. Like there's a servo output on this thing, which is pretty badass. So there's a dedicated PWM output meant for servos on this flight controller, which is not very common, I don't think. But yeah. So the camera connections are up here in the front, which makes sense because, you know, that's where your camera's going to be. And then the VTX connections are here in the back. This Axis Flying video transmitter came with a pretty long cable but I'm gonna have to fish it through the quad. So plug it in here. I'm gonna fish it underneath the VTX, and then thankfully there's little holes in there. It's on the right side here is all the VTX connections. So I'm gonna fish it through the corresponding hole. So let's get that plugged in. Go. There we go. That's the VTX wires taken care of. The camera wires, they'll sort themselves out. It's just gonna go straight from the camera. I'll probably push this down a little bit because, you know, you want to leave yourself some slack. And then the receiver, okay, yeah, so the receiver pads are in the front towards the right. Ground, 4V5, R2, and T2. That's the 4 pads that I'm going to use. To the left of it, there's 3V3 for Spectrum receivers, and then S-Bus down here, and who uses that anymore? So it's all CRSF all the time with ELRS and Crossfire, which is all I run anymore, besides on my whoops. So yeah. To make it look cleaner, I think I'm going to, and then just fold the wires over like this. Just tacked on the sides, and there's not going to be a bunch of wires running across the flight controller. I think for now, I'm just going to use some blue tack to stick the camera down. That way it doesn't move around when I'm trying to solder the wires. Although I could just unplug this. Whatever. This works. This is fine. So yeah, that's all the bits. Receiver, camera, VTX. So that's nothing to it but to do it. Let's turn on the iron. All right, so let's start with the camera. Let's bring the microscope in. Now that we got a clear shot of the area, go ahead and cut this length, which is always a little bit nerve-wracking. Measure it, then leave a little bit more than what's there. You can always cut more off, but it's hard to cut it longer. That's probably good. And this nice silicone wire is really easy to strip just with your fingernails. One trick I learned from Mr. Steele is to just take a length of solder off. Don't use the whole roll because it kind of gets in your way. Good. That just makes it a lot easier when you go to solder it onto the pads. And then of course I have to tin the pads. That. Now this is something that catches a lot of people out. I looked up the manual for this receiver, the RP3 from Radio Master, and I needed to know which wire is the RX and which is the TX. And you would think that, oh yeah, RX goes to the RX pad on the board and TX goes to the TX pad. But no, they had to make it confusing. It's the opposite. The receive pin from one device goes to the transmit pin from the other and vice versa. So one is talking and one is listening. And based on the manual, I'm pretty certain that the outermost wire, the white one, is the RX on the receiver, so that means it goes to the TX on the flight controller. I should probably be using a little bit bigger of a tip. I'm using this bent conical, and it's not the best for this kind of work. It's really meant for really fine work. Probably could have got away with using my fat chisel tip for this, but just hard to get a good angle because of the bentness. There we go. Nice shiny little bubbles. Probably could add a little more flux. Yeah, I really should be using the bigger tip. In fact, I think I'm going to switch to that for the VTX
and that'll just kind of display to you the difference a tip makes. So, okay, we have an option when it comes to this VTX. So you can see here on the microscope, we have 9 volts, ground, VTX T1 and R1. So the options we have here, this little block, you can see they helpfully like outlined it with these dotted lines. This little block is the VTX part. And you can see there's 3 power options in this area. So we have BAT, which is going to be full battery voltage, 5 volts, and 9 volts. Now 9 volt is usually for DJI. That's going to be a filtered supply. And same for the 5 volt. It's going to have a little bit more filtering on it. Whereas BAT is just going to be raw battery voltage. But the VTX I'm using can accept up to 8S, up to 35 volts. And I think to get anywhere near the output power that it claims, which is 3 watts, I'm going to need to be feeding it full 6S voltage, which is what, 25-ish, 24 volts, somewhere around there. So yeah, I'm going to solder the power wire from the VTX to the BAT pad to get full battery voltage. And if it is just a noisy mess, when I turn it on, the video is just unflyably noisy or just annoyingly noisy, I'll switch it to the 9 volt pad and accept the loss in range for improved stability and video quality. But for now, I'm going to solder it to the BAT pad. So I'm going to need to use the ground VTX T1 for tramp control and then BAT for power. So let's go ahead and get these cut to size. These come pre-10 too, but it's just a little bit too much wire. Strip them. I have the larger chisel tip on here, as you can see. Always remember to tin your tips, boys and girls. Wet the tip, as it's called. And let's go ahead and tin these wires. Now let's flux it up. The tip makes all the difference. Okay, well, I didn't record on the microscope. Hopefully I caught it before I started doing the actual soldering. Oh yeah, that's miles better. Okay, good. We're freaking done with soldering. Amazing. Now it's the scary part. We actually have to test it. All right, I'm gonna do a little cleanup just to make it look a little neater. And I'm gonna be using some 99% isopropyl alcohol. Cool, well, looking pretty awesome, if I do say so myself. And we can stick down this receiver. I 3D printed this. It's out of TPU. As you can see, it's like a little rocket shape. There's a little cone on the end. So I should be able to just pop these through. I mean, just use double-sided tape or zip tie. I just like designing things, no matter how unnecessary they are. That went through. There it is. Oh, there we go. Not going nowhere. So what's next? I mean, shit, it's can't really stall it any longer. I think I need to get the top back on. Okay. Now we can plug this wire back in. Okay, battery wire through. Then we have a kitty cat. The people need to see the kitty cat. Kiwi. Okay, enough kitty time. All right, that doesn't look half bad. Test fit an antenna. Yeah, it bottoms out at just the right spot. I'd say that's good. And with this super high powered VTX, it's really important that I do the first power on with an antenna on there because easily burn it out. All right, let's finally get this top on. Plug in this antenna before I forget. Now I can put on these little chin plates and butt plates, whatever it's called. Oh my God, is that it? I think that might be it. I think this might be ready for a test. But first, I will get out the cheapest multimeter of all time, which is my backup multimeter that became my everyday multimeter when my other multimeter died. How many times can I say multimeter? And we're gonna set this multimeter to continuity mode. And that just means when I touch these leads together, it'll make a beep. And what I'm gonna do is I'm just gonna probe the XT60 lead and make sure that we don't have a dead short across the two contacts. And we don't. That seems good. You don't own a smoke stopper, that's one of the best things you can do. And we have a couple choices when it comes to batteries. So I went ahead and got two 6S batteries, thinking maybe we could test them side by side and just get a feel for how different they are. So this is a 2000 milliamp hour freaking brick from China Hobby Line. And then this is a lithium ion pack from A-Line or A-Line or whatever, 4,000 milliamp hours, so double the capacity as this one. These are my two packs, and I think I'll just start with the regular LiPo. Okay, I'm scared. I'm genuinely scared now. Wish me luck. No whammies, no whammies, no whammies, no whammies, no whammies. Oh, yes. It took a moment for the ESC to get to the second beep, so it had me worried there for a second. And the VTX sounds like that. The VTX fan is like actually loud. That's hilarious. I'm gonna unplug this real quick, and I'm gonna get my old box goggles that I use as a monitor these days, my old Eachine 5000D or whatever, and we'll turn it on again and see if we get video. I just took the faceplate part off, but they still work. Right now it's set to race band 8. Which we'll see if that's what it's on, but plug it back in. I think I'm gonna prop it up on here so that the fan can get some airflow for the VTX. Let's just surf through these channels and see if we can get a video. Look at that. It freaking works. Oh my freaking God. Yep. It looks like a good video feed too. It doesn't look half bad. It's pretty extremely fisheye, but all the colors and stuff look great, honestly. Couldn't be happier. And there's not like a whole bunch of frame in the view either. So yeah, that's awesome. I mean, all there is left to do is bind it up to my receiver. All right, let's do that. And I realized that this video is probably gonna be really long, so I think I'm gonna end it here. Once I get this bound up, we'll do the rest of the stuff on the computer, taking a look at Betaflight and the ESC firmware and everything in the next episode. So for now, let's just do the classic binding mode. So I'm gonna actually leave my radio off, and I'm gonna do the 3 quick plugs in order to put the receiver into binding mode. Okay. That was successful. You can see the red double flash. That means it's in bind mode. Now I can turn on my radio, my trusty Radio Master Boxer. And we can go to the ELRS Lewis script. It's all loaded up. Now we can go down here to bind. Did it work? Yeah, it worked. Cool. Now, I don't think, because yeah, none of the modes are set or anything, but it's freaking working. We've got telemetry on the radio. Drone puts out a video. I'm so ecstatic. I'm so happy this worked. I'm questioning why I waited so long for this build. It was really fun. So glad that I got to this point. And yeah, so glad that y'all came along. This is gonna be sick quad. I cannot wait.
Telemetry lost.
Yes, telemetry was lost. I unplugged the drone. It's looking pretty freaking sweet. It's a little unorthodox with the way I have the VTX arranged, and I don't know, it's got charm to it, all my custom printed parts. And also, for the next video, it's not gonna be just Betaflight stuff. We will be adding this thing. This is a active buzzer that has a battery backup. So if you crash a quad and it's really far away and it gets unplugged somehow, this will start to beep and flash a really bright LED to let you know that it's in need of help. And one other thing, I also got these, which are Speedy Bee LED strips that I also designed and 3D printed this little bracket, and that's gonna go underneath the arms, a little something like that. So I'm gonna take off the old zip ties and zip tie those kind of in the same spot, but on the other underside. RGB is the best. But yeah, that's gonna be it. Thanks for sticking around for this one. This was a lot of fun, and I'm super relieved that this part of it's done and it didn't go up in a flaming ball. So if you enjoyed this video, go ahead and get subscribed. And obviously, if you want to see the transformations that this goes through, all the other extra add-ons that I have in store, yeah, just get subscribed and you'll see those videos. Yeah, thanks for watching. See you guys next time.